Hello again, Joys of Trigonometry, Part 61. In all seriousness, here we go with Sum and Difference Identities from Chapter 7. Go through a couple of examples. First of all, here are the formulas that we went over in class. So obviously we've got sine of a plus or minus b. Now again, remember what we're saying here is that if this is, you follow the top. So if this is plus, we're going to go plus here, minus, minus. So sine is sine, cosine, cosine, sine. Cosine of a plus b, you swap the sign. So if again, top, following the top, you've got plus here, come over to minus. If you're subtracting the two angles, then you're going to do a sum of these things. And it's cosine, cosine, sine, sine. And then tangent again. Now notice, remember over here, one way you can do it if you wanted to, and we derived it this way, is sine of a plus b over cosine of a plus b. Now remember sine over cosine, and that's why how I will tell you to remember, am I adding or subtracting on these? Since sine's on the top, you're going to match plus for plus, minus for minus. Since cosine's on the bottom, you're going to switch it. So if you're adding on the bottom, you're going to or if you're adding the two tangent angles, you're going to subtract down here. Okay, so with those in mind, I want to go through a couple of two different types of examples like you see in your homework and on the review sheets, and then hopefully that'll help you get ready for the reality check on Friday. So, example number 1. Let's say that we've got sine of x is negative 5/13. Tangent of y is 2/3. Both angles are in quadrant 3. Why is that important? The reason why it's important is because that will tell you which, it's sine or cosine, positive, negative, that type of thing. And so we're going to go through and we're going to find sine of x plus y, cosine of x plus y, tangent of x plus y, and then find the quadrant where x plus y exists. Step 1, draw your triangles. So draw triangles to get the missing trig functions. Now, I'm going to go through this. I'm not going to go into great detail because we covered this in Chapter 5. We reviewed it in Chapter 6. We reviewed it again here in Chapter 7. Okay, and all of this stuff is stuff that you may have done at the end of Algebra 1, but for sure did in right triangle trig unit last year in geometry, whether it was honors or regular. So for angle x, here, again, we're in quadrant 3. One of your sides is always going to be the horizontal. The other one is always going to be coming from the origin to the end of this line right here. Okay, so the sine is opposite over hypotenuse, right? So I've got negative 5 is here, 13 is here. It's a Pythagorean triple. Sorry, just trying to clear that out of the way a little bit. So 5, 12, 13 is a Pythagorean triple. Since quadrant 3, this has to be negative. Okay. And so for this, we've got cosine of x is going to equal negative 12/13 because that's adjacent of hypotenuse. And then the tangent of x is going to be a 5/12 because it's going to be opposite, which is negative 5 over negative 12, can become positive. For angle y, again, we're in quadrant 3. Doesn't have to be perfect. A rough guess will work. But now we've got tangent, so that means this is going to be 2. This is going to be 3. Now again, we're in quadrant 3, so those two sides, opposite over adjacent, need to end up being negative. Because again, we're talking about quadrant 3. Sine is negative in quadrant 3. Cosine is negative in quadrant 3. Any point you have in quadrant 3 has x and y values negative. So now you're going to square these, Pythagorean theorem, and I'm going to come up with root 13 here. So that means for that, okay, I'm going to sine is going to be a negative 2 over root 13, which after it's rationalized, excuse me, let me move this so it's a little bit better. I'm going to rewrite just for clarity's sake. So sine of y is equal to a negative 2 over root 13. When we rationalize it, so we're going to multiply by root 13 over root 13, I now have sine of y is going to equal a negative 2 root 13 over 13. Cosine, likewise, is going to be adjacent over hypotenuse, so it's going to be negative 3 over root 13, so that's going to turn out to be a negative 3 root 13 over 13. Okay, so we've got sine of x plus y. So sine of x plus y, and again, to help memorize this stuff, I would write out all the formulas first. Sine of x cosine y plus cosine x sine y. If it's sine, remember the order goes sine, cosine, cosine, sine. Sine of x. So you look up at sine of x and you say, wow, that's a negative 5/13. And you've got cosine of y. That is a negative 3 root 13 over 13. Plus cosine of x, which is a negative 12/13. Times the sine of y, which is a negative 2 root 13 over 13. Simplify this. Common denominator is going to be 169. Across the top, negative 5 times negative 3 root 13. Sorry for the awkward pause. I had to go deal with something and pause the whole presentation. So you multiply across the top. So now I've got, that's going to be 15 root 13 plus 24 root 13. So then your final answer, since you've got common, since you can essentially like terms there, you'll end up with 39 root 13 all over 169. 39 and 13 are both divisible by 13, so then you can change it to 3 root 13 over 13. Ta-da! And cosine is going to be very, very similar to that. Obviously, these all take some work and a lot of space, so I'm going to give ourselves a little bit of space here. So cosine of x plus y is equal to cosine x cosine y. And now remember, you change the sign. So since I'm adding here, I'm going to subtract in between the two. So cosine of x is at the negative 2 root 13 over 13. Cosine of y is the negative 3 root 13 over 13. So we'll get some rid of the radicals on that one. And then sine of x, sine of y. Sine of x, you know what, my apologies, oops, this raise is fallible. Cosine of x is negative 12/13. So cosine x, cosine y, cosine x, cosine y. Sine of x is a negative 5/13. And then sine of y would appear to be negative 2 root 13 over 13. And again, now you're just going to simplify this. And I say that somewhat nonchalantly, and I kind of mean it that way because you should be able to do this. Common denominator here is going to be 169, 13 squared. I'm going to come up with 36 root 13 minus, and then this is going to become 10 root 13. So that's going to simplify out to become 26 root 13 by the time we combine the radicals, or 69. Again, this is both 26 and 69. Excuse me, 169 is divisible by 13, so that's going to become 2 root 13 over 13. At this point, you know where the angle x plus y is going to end up. And again, let's see. Actually, I'll start a new page. Oops. So where is x plus y? Okay, sine of x plus y is 3 root 13 over 13. Okay, cosine of x plus y is 2 root 13 over 13. Now, The numbers are not important, their signs are. Think back to where quadrants are. Okay. Quadrant 1, positive, positive. Quadrant 2, negative, positive. Quadrant 3, we have negative, negative. Quadrant 4, we have positive, negative. Also remember back to the unit circle, cosine comes first, sine comes second. So in our case, from what we have up here, okay, we've got a positive cosine and a positive sine. The only place where that happens is going to be quadrant 1. So x plus y is in quadrant 1. Now, if for some reason we made a mistake, and obviously you've seen me do it, so it could happen, but if we made a mistake, the tangent of x plus y will help verify that, because if we're in quadrant 1, tangent's going to be positive, because again, remember, you've got you know, anything going from quadrant 3 to quadrant 1, you're going up and to the right, and that's going to be a positive slope. So we'll go through and double check that. Now our tangent numbers here, just 5/12 and 2/3. So when we do the tangent one, let's take a look at that. Okay, so tangent of x equals 5/12. Tangent of y is equal to 2/3. So again, remember, tangent of x plus y is going to equal tangent of x plus tangent of y, and the reason why it's adding is because it matches up with sine, so the top matches, the bottom is going to be the reverse, so it's going to be 1 minus tangent of x times tangent of y. So in this case, we're just going to plot points in. Now again, it's going to look scary. It's going to be a little scary. Remember, however, we did rational functions back first semester. Okay? Breathe, take your time, and you can do it. But this is actually going to be even easier for the simple fact that you're going to have the same common denominator. In this case 36 in the numerator and in the denominator, on both mini fractions. If you have the same denominator in the both mini fractions, those are going to drop. Okay, so on the bottom here, we're going to end up with this part over here is going to be 10 over 36 because it's 5/12 times 2/3. This I'm going to multiply through by 36 over 36, so that's 1, and we're just going to change into that. Here in the numerator, we're going to multiply through by 3/3 and 12/12. So then I'm going to get 15/36 plus 24/36. Simplify the top and the bottom. On the bottom, I come up with 26/36. On the top, I now have 39/36. So that means the two bottoms are going to divide out, or if you want to, you can divide a fraction. If you divide two fractions, multiply by the reciprocal. And you're going to end up with an intermediate fraction of 39/26, which then will reduce to 3/2 when you divide out a 13. And that is your tangent of x plus y. And we are in quadrant 1. It's from what we saw before, so that should be good enough to get what we need. And sure enough, we are. So we're set to go. So that's how you do it when they give you values for the trig function of an angle. The other type of problems you're going to see are things like this, where they say, okay, find sine of negative 75 degrees, or find tangent of 11 pi over 12. These angles here are ones that are going to be based off of ones that you know for the unit circle. And this is where, everything we knew from the unit circle is important. It does not matter which two angles you use, so as much as that they add up or subtract out to be sine of 75. So like in this case here, I could have written this as, okay, we get to write this as sine of a negative 30 plus a negative 45 degrees. Or you could do it as sine of a negative 30 degrees minus 45 degrees. That would work. You could also do, what else? You could do like 120 minus 45. So you could do sine of 120 degrees minus 45 degrees. Take that back all the way around. 45 minus 120. I was just shooting for 75 there. We'll just flip the two around. So 45 minus 120 degrees that would work as well. So any of those you could set up to do. I'm going to do, I think the first one, just because the numbers are going to be a little bit easier here. So sine 7, so we're going to go sine of negative 30 degrees plus a negative 45 degrees. Now, it doesn't matter which one you use, because the sine values will change, or the trig values will change, and when the trig value changes signs, then that'll take care of the plus or minus thing. But now remember, this is going to be sine of 30, it can be negative 30, and then cosine of negative 45 plus cosine, of negative 30 sine of negative 45. So sine of 30 is, now remember, on the unit circle, you've got all your coordinates. So at 30 degrees right here, you've got the coordinates root 3 over 2 and 1/2. And if we're talking about negative, then we're now talking about, this will be root 3 over 2 and negative 1/2. So sine of negative 30 is a negative 1/2. Cosine of 45 degrees, negative 45 degrees, is going to be root 2 over 2. Plus cosine of negative 30, we have over here, but it's the x value, so that's going to be root 3 over 2. And the sine of negative 45 degrees will be, now again, it's like root 2 over 2, root 2 over 2, so you're going to go down, so that's going to be a negative root 2 over 2. And this is where I was saying, if we had done this one right here, this would be sine of regular 45, so it would be just root 2 over 2, not negative root 2 over 2. But then this would be minus, so it kind of all takes care of itself. And to make sure that that looks appropriate, we go like that. And now you just simplify it. Common denominator is going to be 4. So you're going to get a negative root 2 minus root 6 all over 4. No, you may not reduce it. No, you may not combine the two radicals. Do not pass code. Do not collect $200. Now, the same thing holds true for these with radians. Now, you have two options here. I'm going to go ahead and do it in radians for you. If you get stuck or if you're not sure, you can always change the radians. So you can always change the radians into degrees. And then it's usually easier to see oftentimes. Oops. Okay, so in this case, 11 pi over 12, if you're forgetting your information from chapter 6. Remember, conversion is 180 over pi, so you're going to go 180 over pi, multiply that out, and you should come up with 165 degrees. Ta-da! And then at that point, you would say, oh, well, that's like 120 plus 45 degrees. Okay. If you were to do it in terms of radians, what I would suggest doing is this, is on your circles, you've got pi over 6, pi over 4, pi over 3, pi over 2, and then convert all those into 12ths. Okay, so you would say, okay, that's 2 pi over 12. You're going to say, okay, that is 3 pi over 12. This is 4 pi over 12. That's 6 pi over 12. And you're going to find some that add up to become 11 pi over 12. Okay, so we'll go ahead and just do the degrees ones, just to be safe. And so we got tangent of 165. You can do this a whole bunch of different ways. I'm going to write this as tangent of 45 degrees plus 120 degrees. You have to be careful, particularly when you're doing tangent, about seeing, or you're not taking 90-degree angles. For sine and cosine, it's not that big of a deal, but for sine and cosine, or for tangent, it can be, because obviously tangent of 90 degrees is undefined, so that would not be helpful in terms of trying to find out your things. So again, tangent of 45 plus 120 is going to equal the tangent of 45 plus the tangent of 120 over 1 minus the tangent of 45 times the tangent of 120. So for that, this is where things can kind of get sticky. And again, go back to the unit circle. These little boards definitely don't make them pretty. Now remember, everything on the unit circle, cosine, sine in terms of coordinates. So at 45 degrees, that's going to give me root 2 over 2, root 2 over 2. Okay, here's my cosine, here's my sine. Also remember that tangent is going to equal sine over cosine. So in this case, I've got root 2 over 2 divided by root 2 over 2, which is then 1. So the tangent of 45 degrees is going to be 1. At 120 degrees, I'm up over here. The coordinates there are negative 1/2 and root 3 over 2. So again, cosine, sine. Tangent of 120 degrees is going to equal root 3 over 2 over a negative 1/2. So that's going to equal a negative square root of 3. So those are the numbers that we're going to plug in here. Block this off just a tad. So if I follow this out, I've got now 1 plus a negative root 3 all over 1 minus 1 times a negative root 3. So if I simplify that out, I'm going to get 1 minus root 3 over 1 plus root 3. Now again, don't be tempted to stop here, because you still need to rationalize this. To rationalize this, we need to go through and multiply this out by the conjugate of the denominator. The conjugate of the denominator is 1 minus root 3. So on the bottom, I now have 1 minus 3, because again, difference of perfect squares. On the top, I've got 1 in the front, minus 2 root 3 plus 3. So on the top, I now have 4 minus 2 root 3 over negative 2. So divide a negative 2 into both parts, and this now will become negative 2 plus root 3. And that will be your tangent of 165 degrees. Okay, so this ends the 7-3 stuff. It was rather long, but there's lots of stuff to cover. I will see you in class, and obviously call or text if you have any questions. Thanks. See you later.